Alright, excitation system and power plant regulation. American Locomotive Company Diesel Electric General Electric Locomotive Model 244 engines. Elco Diesel Electric Locomotive School Instruction Series number 803. Excitation system power plant regulation. Section 1 propulsion equipment. Section 2 excitation system. Section 3 power plant regulating system within 17 MG3 governor. Section 4 power plant regulating with a 17 MG6 governor. All right, page 2 propulsion equipment. American Locomotive General Electric's IS 8 instructional schooling 800A 150. Section propulsion equipment. Propulsion equipment for the Elco GE road locomotives include the diesel engine, traction generator, traction motor, excitation system. Locomotive source of power of the Elco model 244 V-type super turbo supercharged four-stroke cycle diesel engine at 9 to 10.5 inch 12-cylinder engine. Installed each road freight and road switching locomotive. A 16-cylinder 9, 10.5 inch engine is installed each of the railroad passenger locomotive with the multiple machine horsepower, mechanical horsepower developed the diesel engine converted with electrical power locomotive traction generator, the traction generator of the freight and road switching locomotive, the GE electrical type GT564 North pole and 10 pole directing current commutating pole type, the separated excited shunt generator of the same description fits the traction generator of the passenger locomotive, except that the later is the 12 pole type GT566. Traction generator armature is directly coupled to the diesel engine crankshaft. The engine of the crankshaft rotates the armature. The armature has generally the cylindrical shape made of laminated iron, insulated copper conductors as laid out slab the cuts lengthwise and surfaces of the cylinders. As the armature is rotated, the diesel engine is the conductors cut across the magnetic lines of force which are produced with the electrical magnetic poles piece of the traction generator. The magnetic lines of force are usually referred to as flux lines or flux. The pole piece of each of the consists of black iron around which the wound is a coil with a wire called field winding or field coil. When the current of a small generator is called the exciter is passed through the field winding, the iron pole pieces will become magnetized. Flux lines will pass through the one pole piece through another. The armature is rotated. The conductors pass through the pole pieces and cuts across the flux lines. When the conductor cuts the flux and voltage electrical pressure with the generated item, the strength and generated voltage depends on how many flux lines the conductor cuts at a given time. If only a few flux lines are cut, voltage will be weak. If many lines are cut, the voltage will be strong. The voltage can be varied as follows. 1. By varying the number of flux lines, by varying the speed of the conductors, by varying the speed of the flux. Alright, the line with a dash through it, a straight line with a arrowhead in the middle of it indicates the direction of field current flow. A curvature line with an arrowhead in front of it to indicate the direct armature of the conductors. It shows your traction motor field windings on the outside of motor 1, 2, 3, and 4, brushes and armature motor arms and motor frames. But this all starts from the generator frame, which has the GE armature conductors, which travels on the main path through the generator field contractor, through the traction motors. Also, the generator armature pole piece and generator field winding. The exciter field winding on the generator frame goes to the exciter armature with a pole piece and exciter frame and generator field contactor, which keeps the circuit running. Thus, the flux will be may be variable with the changing of the current exciter supply with the field winding that's increased with the current with the increase of the number of the flux lines decreased with the current with the opposite effect. The speed of the conductors may vary with the changing of the speed of the diesel engine. Slowing the diesel engine speed will decrease the rotational speed of the traction generator armature. So if the conductor speed increase the diesel engine speed will increase the conductor speed. The voltage will be generated with the traction generator armature of the conductor whenever the armature is being rotated with the diesel engine. The exciter is supplying the field winding with the current magnetizing the pole pieces. But rotation and field current must exist at the same time. The armature conductor will connect with one of many copper bars which over the generator communicated with the brushes in which in the contact with the communicator bars are connected. The traction motor closing the switch called the contactor. The complete circuit from the traction generator armature conductor to the traction motor will exist. It's heavy lines is shown in figure 5.1 shows the circuit with the complete circuit exists. The voltage traction generator armature conductor will push current through the connecting cable to the traction motor. The amount amount of the current flow with the traction motor depends on two things: the resistance of the traction motor cable with the connect with the traction generator, B, the strength of the voltage developed on the traction generator. The traction motor used in the American Locomotive Company and the GE locomotives with the 244 type engines or General Electric type, the GE 752 4-pole direct current series wound communicating pole or motors with a single reduction gearing with a connecting the armature shaft located the driving axle. The current which the traction generator supplied with the traction motor will cause to develop the torque with the rotate the motor armature of the turning the driving axle to produce low motive movement. The traction generator each of the locomotive in the unit supply powers with the 4 traction motor, which is represented by the number 1, 2, 3, 4, is shown in figure 1 and 2. When the engine man desires to move the locomotive to the train, he operates the locomotive throttle selector handle and reverse handle movement of the lever. The desired position will cause the power contact which clove the traction generator field winding will be energized with the current of the exciter and the generator armature being rotated with the diesel engine current, which will reach the traction motor to produce locomotive movement. The excitation system of the locomotive acts to make the diesel engine and the traction generator operate with it together with the efficiency with the control of the amount of the current with the exciter. Lever the traction generator of the field winding. The excitation system will automatically vary the field current to the suit operation conditions, as will be explained in detail later in this instruction. The excitation system will decrease the generated field current if the diesel engine traction generator is in danger or overload. It does this, decreasing the exciter field current. The exciter 2 is generated with the armature in the field winding. The current which the exciter supply of the generated field can be varied by the varying exciter's field current. Alright, figure 1 illustrated the fundamental 2-pole generator with a 4 traction motor with the connected with the series parallel current and connection with the figure 2 show the generator motors as they will be illustrated in the wire diagram. The generator is represented with a circle with a G in it, and each of the traction motor is represented with a circle with a number in it. The field windings of both the generator and motor are represented with a zigzag symbol, and these symbols of the circle and zigzag will be thoroughly instruction representing with the armature and field winding of the motor and generator. So, figure 2 shows, figure 3 illustrates the relationship of the diesel engine main generator exciter traction motor with the position they occupy in the locomotive. You have your generator, and it follows the path in 2 parallel circuits between the traction motors 1, 3, and 2 and 4 with motor field windings at each motor armature. Your traction motor generator field contactor field generator with the exciter armature with the exciter field. Alright, diesel engine show the traction motor, wheels, and generator engine, diesel engine, and traction motor. Alright, the excitation system of the power plant regulating system work with very close with the coordination with the two of the most important parts of the diesel electrical control locomotive. The excitation system control of the traction generator operating with the power of the plant regulation system control of the diesel engine operates with the fact that the diesel engine mechanical equipment, the traction generator electrical equipment, they're combined with the supply. The power which drives the locomotive things involve radically different. The equipment, the most of them together with the efficiently if they were left on their own desired devices, that is, and without any of the control equipment, with the regulate with their own operating, and the efficient operation would be impossible. Controlling the diesel engine operation. The engine man who operates the locomotive is provided with a throttle. The throttle has an idle position and 8 power positions numbered 1 through 8. The advantages of the throttle 1 power position to each for the other diesel engine will increase the speed with one constant number of the RPMs to another constant number of RPM. But the throttle advantage for the cover of the power plant regulation system to allow the increase of the fuel injection, increase of the quantity of the fuel will make the engine run faster. The throttle in any one of the several positions for the power plant regulating speed will regulate the fuel injection generator load in such a manner that the engine speed will be held with the constant in accordance with the table 1 by the time. Term engine speed used throughout the instruction is met with the diesel engine revolutions per minute, but not the locomotives per mile per hour. Our throttle position idled 1 has 350 RPMs, 2 has 450 RPMs, throttle position 3 has 550 RPMs, throttle position 4 has 655 RPMs, throttle position 5 has 765 RPMs, engine speed 6, the throttle position has a engine speed of 860 RPMs, 7 has an engine speed of 920 RPMs, and 8 has a throttle speed of engine speed at 100,000 RPMs. It's important for the engine speed with the held the constant with each of the throttle position with allowed with the surge for the recover the horsepower over the engine. The surge horsepower surges must smooth train have a difficult job, but this should be held with the minimum of the throttle plant with the regulating has just the job of keeping the engine constant with the throttle position, changing the engine speed whenever the power positions change. The power plant regulating system throughout the governor accomplishes this because the control of the operation of the diesel engine fuel with the fuel injection pump will instead of with a steady unchanged level of the engine with the speed with the constant as long as the rate of the fuel injection is held constant with the fuel injection increase. With the engine speed with the increase the fuel injection decrease, the engine speed will decrease. It will load the diesel engine increase, the engine will slow down. The governor will immediately increase the fuel injection to bring the speed up again. With the diesel engine decrease, the engine tends to speed up, but the governor will decrease the fuel injection, bringing the engine back to the proper speed. Thus, the speed of the diesel engine can be affected in two ways: A, by changing the load; B, by changing the quantity of the fuel injected. The governor primary function for the control engine speed through should there be, therefore, for the capable of controlling both fuel injection and load, both in the affected speed. The 17 mg3 governor control for both fuel injection and load. In addition, for the control which has already been mentioned, with the governor equipment that includes the rheostat, which acts as the variable resistance in the exciter field circuit. As the governor is also engine speed of the fuel injection with additional load slow for the engine below its rated speed. The governor will cause the load of the control rheostat to add resistance for the exciter field circuit. With the resistance added with the circuit, the current in the circuit will reduce. The exciter field current reduces the exciter output current with the supply with the traction generator field will reduce the electrical load with the traction generator. Thus allows the engine speed to regain its speed. Thus action is called the load of the control, as in fully explained with the power plant regulating system in section 3. Traction generator. Load of the control with mentioned above. The type of the traction generator with the control, but I've referred to the diesel engine control because of the primary concern for the diesel engine excitation system control for the power output with the traction generator. The output must be properly controlled with the efficient with the operation. With the equivalent damage will result with the traction generator converts the horsepower of the diesel engine into the voltage current. The latter two combines with the produce the electrical power with the voltage output for the given side of the generator depends on the speed at which the armature is rotated with the amount of flux produced with the magnetized pole. Piece of the flux depends on the exciting current that has been passed with the field winding, but the excitation system with the control of the amount of the current with the flow through the field winding, therefore control the voltage output with the generator and doing the protect for the generator and successive voltage and current which has damaged the generator. It is important that the voltage current be prevented with exceeding with the safety limits of the generation permitted with the generator to high voltage generators. Insulation might be damaged. Voltage electrical pressure, excessive electrical pressure will puncture the insulation. Other type of excessive electrical access is too much current flow will have a different effect. The flow of the current causes the heat. Too much of the current flow through the generator conducted with the generator. Excessive heat with the generator insulation would eventually be destroyed by high temperature. The icing system through the control of the generator field current can prevent the generation too much voltage, too much current. Whenever either excess occur, the excitation system automatically reduces the generator field current with reduce the field current with the voltage current with the output with the generators reduced. The overloads are prevented. Or your traction generator and current control. As well as designed in a well-designed diesel-electric locomotive, with no type of overload will ever occur with the same type of the very, very low locomotive speeds. With a heavy train with the beginning with the start of the high current with the high being generated with the traction generator, the excitation system should control the current to prevent the becoming the excess of the generator. Excitation system should use the prepare suitable core reactors to measure the generator of the output current for the depending on determining its value. If it is excessive, the reactors will act to reduce the exciter field of current and bringing the traction generator output of the current down to the safe value. This is called the current limit control of the load current control. This is fully explained in section 2. The locomotive accelerates the trains. The traction generator current reduces to within 65 miles gearing with a speed of 9 to 10 miles per hour is reached with the current will have to reduce the valve value which no longer serviceably overheat with the traction generator. Danger of the current overload is now minimized. Engine loading current. When the locomotive accelerates its train from 0 to 10 miles per hour with the horsepower output of the engine and voltage of the traction generator increase the low speed of the locomotive speed. The horsepower, depending on the engine, depends on the amount of the voltage current generated with the traction generator. The product of the voltage of the current is in watts. Voltage times amps equals watts. Unit of electrical power in watts, 746 watts is equal to 1 horsepower. At the speed of the 10 miles per hour with a high attractive effort with needed with the train rolling, and the higher current with the below will cause the traction motor to produce the necessary attractive effort. But although the current is high, the voltage is quite low. Therefore, the total watts of the generator represent the horsepower demanded on the diesel engine. Within the engine can easily meet the locomotive acceleration voltage increase with the current decrease, and the former increase with a more rapid rate within current with the decreases. The watt increase of the diesel engine must supply with the generator is steadily increasing the horsepower in order to generate may produce these watts. At about 10 miles per hour, the diesel engine will develop its full rated horsepower in order to meet the demands of the generator. Further locomotive acceleration would require the steady increase of the horsepower generator output of the watts of the prevented by the increase of the natural characteristic of the generator would be for this watt is to increase the locomotive accelerated to about 13 to 14 miles per hour with a decrease for the further acceleration to 18 miles per hour with both the characteristics would allow the generator to overload the diesel engine. The overload is prevented with the load control system with the act of preventing the generator increasing in its watts above the well voltage value with what is produced approximately with the 10 miles per hour. By doing this, it will protect the diesel engine against the too high horsepower demanded by the generator. The load control system is operated with the diesel engine governor function whenever the gun generator would normally attempt to overload the engine. If the matches with the generator output with the engine ability to supply with the horsepower on a 65 miles an hour geared locomotive, the load control system functions with the speed range of between approximately 10 miles per hour and 60 miles per hour. The transition points for 18, 24, and 50 miles per hour. It does not reduce generator watts, but below them they would normally be set with these points because of the normally voltage normal wattage. These speeds would be the same as it was 10 miles per hour. The volt wattage of the previously mentioned would not cause the engine overload. Or your traction generator voltage current. The locomotive accelerates and the train traction generator voltage increase the curve because of the excitation system permits the generator field current to increase in order to voltage will increase the increasing voltage of the traction motor speed. The increase of this will cause the course of accelerate the train with the transition point of the maximum locomotive speed. The traction generator field current, hence the traction generator voltage will be maximum value. Increase of the field current will overheat the field winding and damage it. And the second pair with the suitable saturable core reactors is used to measure the field current. With the field current exceeding the maximum safety value, the reactors automatically reduce the current exciter field. This causes this of course reduces the exciter output with the generator field. The generator field current is then prevented from reaching the value of the well, overheating the field winding, converting the action with the reactors. This is called the field current limit, but fully explained in section 2. By preventing the field current with exceeding the minimum safety value, the generator voltage is also made at a maximum safe value because of the voltage depends on number of flux lines that the generator conductors cut in a given time. And the limiting field of the current flux is limited, therefore, as so is voltage. Voltage ampere curve. The voltage ampere curve curve figure 5A with the graphic picture of the voltage equivalent value of the generator of the traction generator locomotive. While the locomotive is acceleration train from 0 speed to about 18 miles per hour, the curve of the figure 5A represents the traction generator of the current voltage with it, which would result in the during 8-notch operation with a diesel engine with 1,000 RPMs. Load figure A shows the figure load current, the voltage from D, maximum field current, maximum horsepower, maximum load current. Voltage 5, figure 5B shows the voltage, X and D, the excessive field current with the excessive high pressure and the excessive current. Alright, a zero locomotive speed before the traction motor is being rotating the voltage current, the void value of the BA with the maximum current volt with the very low voltage of the current is high because of the resistance of the traction motor there connecting the cable to very small voltage low because of the excitation system reduced the field with the current with the very low value of the field current with the reduced for the low value of the traction generator vendor for the voltage with a higher and excess for the current with the such for the representative of the shaded area of the figure 5B would result. Except for the current which would cause wheel slippage, sparking of the traction generator brushes and overheating the generator and traction motor. Alright, so this excessive current, this shaded inversion, would also cause the stressing of the sparking of the traction motor, wheel slippage, and damage to the brush and generator and traction motor. If the locomotive begins to move with the traction motor being of the generator with the counter with the voltage of the output with the flow of the current of the traction generator, the generator current is forced to reduce the locomotive accelerates, and however the voltage increases because of the excitation system that permits the generator field the current increase. The increased voltage prevents the current from dropping off too sharply. Point B with the curve that represents the voltage current value with the would-be generator locomotive speed of 9-10 miles per hour with a diesel engine developed. It must be fully rated horsepower in this point. Further acceleration would cause the increased voltage gradually decrease with the current in line with the BZ with the figure 5B with the voltage current value would represent the grade with the horsepower demand on the engine overload would result to prevent the load current control system reducing excitation with the volt current with the value that are held at B line BC figure A5A. Voltage current values at this point would represent maximum safe engine horsepower. So B to C. That's your maximum horsepower, maximum B to A, maximum load current, B to D to C, maximum field current. Alright, and approaching accelerated voltage increase with the current decrease along the BC until the 18 miles per hour point at C is reached the field current. At this point, it is approaching with the maximum safe value with the preventing with the increase of the further field current limiting system overheating the generator field coils is avoided. The limiting load current with the engine horsepower output the field current voltage amperage curve with the figure 5A result with the excitation system design and with the limitation of excessive value with the shown in figure 5B with the result in poor operation equipment overload could not be avoided. Alright, this shows figure 6 shows the generator output determined by the limitation engine power maximum generator field with the current with the generator load current. Alright, your output voltage, maximum field current, maximum engine power, maximum load current. Main generator to the field CP, field winding around the traction, four-sided ampidine exciter resistor fuse 1, fuse 2, curve battery, output generator, generator load current, output curve, too much field current, too much power, too much load current. Alright, section 2, excitation systems.